All right, welcome to segment 2 of the course. In segment 1, we talked about a lot of the basics of statistics, including what are data, what variables are, sampling methods, designing studies. We also talked about different graphing techniques. In this segment, we're going to turn our attention to quantitative analysis. Let's look at it this way. We have two different types of variables, quantitative and categorical. We have talked about how to visualize data for both quantitative and categorical data. But how are we going to discover patterns in the data? Well, we have a couple of tools for that. For quantitative data, we're going to use summary statistics. This includes the mean, median, mode, quartiles. All four of those help us to find the center of our data set. Where is the middle of our data set located on the number line? Then we also talk about standard deviation and z-score. Those help us to understand how spread out is the data from that center point. The center data, that's what we're talking about here in this lesson, lesson 6. Standard deviation and z-score, where we talk about the spread of the data, that's lesson 7. Then correlation is when you take two quantitative variables and you see how integrated they are, how one variable responds to another. This is correlation. This will be in lesson 8. All of these combined make up what we call summary statistics, and this is the focus of segment 2. When we're done, we'll get into segment 3, where we can discover patterns in categorical data. Our primary tool there will be probability. We'll get to that one when we're done with segment 2. So let's dive into lesson 6, measuring the center of our data. Now, there are 3 main ways to measure the center: the mean, median, and mode. The rest of this video will talk about mean. I'll talk about the other 2 in other videos. Now, I like to think of the mean as a middle point. Very much like a balance point of 2 people on a seesaw. If you can get them positioned anywhere on the board, you move the fulcrum or the balance point to that point where the 2 people on the seesaw are perfectly balanced. That is the center of mass, if you want to think of it from a physics perspective. It's the center of the mass of the 2 people. How can we calculate the mean, or that center, the fulcrum of our numbers? Well, it's very easy. All you have to do is add up all the numbers you're dealing with and divide by the number of values you had to add together. So this first equation I have on the screen here, this is simply what it is. Let me get my laser pointer here so you can see what I'm pointing at. So yeah, you just add all the numbers together, divide by however many numbers there are. N is always going to be the number of values, or our sample size is what we often call this. Okay. Now this notation here may look very strange, but let me tell you, it's actually not that hard. This thing that looks like a weird E, that is the Greek letter sigma. And it's the Greek version of our letter S. So we use S for sum. So this is the sum of all of your values xi. Okay. It just means add all the numbers together. That's all it means. Sum of all of your values divided by your sample size n. All right, so let's do this first question. What is the average of 5 and 9? Just like the 2 people on our seesaw, what is the middle point in between? Hopefully you can visualize this already. If you have the number 5 and the number 9, the number right in between both of those should be 7. Well, mathematically, what do? We add the 2 numbers. 5 plus 9 is 14. Divide that by however many numbers I had to add together. There are only 2 numbers in this case. 14 divided by 2 is 7. Sure enough, the middle between 5 and 9 is 7. But let's go back to our seesaw example. What happens if you instead have two people on one side and one person on the other side? Well, then that makes it a little more heavy on that one side. And so you could take your fulcrum, that balancing point, and shift it towards the side where there are two people. And you'll be able to balance that way. That would be your balancing point as that fulcrum is shifted towards where there are more people. Likewise, when there is more data on one side, it's going to shift the mean in that direction. The mean is just that fulcrum. Remember, it's the balancing point, the middle of all your numbers. So what's the average of 4, 5, and 9? It's the same problem as we had before, but this time we have an extra data point very near the 5. So it's 4, 5, and 9. Now, essentially, one way to think of this before we actually do the calculation is that now that we have a 4, which is close to the 5, the middle should shift closer towards that 4 and the 5. And if it does that, then our mean should drop. It should be below 7 because it's going to be weighted more towards these two. All right, so how do we do it? How do we find the mean? We add them all together and divide by however many numbers there are. So it's 4 plus 5 plus 9, which is 18, divided by the number of points we have, which is 3. 18 divided by 3 is 6. All right, so sure enough, the average dropped from 7 down to 6. And so it shifted the mean towards the 4 and the 5. Perfect. So calculating the mean for a population versus for a sample, it's done exactly the same way. The equation is exactly the same. However, to distinguish from a population and a sample, we're going to indicate the mean with slightly different characters. When we take the population mean, we're going to use this funny looking U. This is actually the Greek letter mu, and it is the Greek letter M. It's their version of our M. And so M for mean, we're going to use their mu. Now, often you'll see this through the course. If we throw in a Greek letter, it's because we're generally talking about a population. Just be aware of that. If there's a Greek letter, we're generally talking about a population. The one exception is this letter that I showed you earlier, and that's just a general symbol meaning sum. Sorry, that was a bit of a side note, but good for you to know. So population mean, we're going to calculate using the Greek mu. Sample mean, we're going to say x with a bar over it. I'll just call it x bar or sample mean. Okay, but they're both calculated exactly the same way. You add up all the numbers together and divide it by the number of values you have. Granted, for the population mean, that's going to be a huge list of numbers because populations are huge. That's why we have samples. They don't have to be so big. Anyway, that is the mean. In our next video, we're going to talk about the mode.